So suppose that we wanted to go through the whole process of diagonalizing this matrix. I need to find eigenvalues and eigenvectors. The first thing that I'm going to do is find my eigenvalues. So I investigate the determinant of A minus lambda I. That will give me the characteristic polynomial of this matrix. A number lambda is an eigenvalue of this matrix if and only if the determinant of A minus lambda times the identity is 0. So I have two eigenvalues. Lambda equals 7 and lambda equals 2. To determine eigenvectors, I'm going to subtract the eigenvalue times the identity. All right? That means that I only subtract it from the diagonal. Subtracting 7 gives me that matrix. The eigenspace associated with eigenvalue 7 is the null space of this matrix. Now, I find it easier when working by hand to use vectors with integer components. So I'm going to choose 2, 1. That will span the eigenspace associated with lambda equals 7. What about lambda equals 2? Well, I'll subtract 2 times the identity from matrix A. Clearly, 3, -1 will work as an eigenvector associated with lambda equals 2. So now, I can write a basis for R2 by including each of these vectors. An eigenbasis associated with matrix A. My change of basis matrix would be that matrix. Its inverse swap, negate is given like that. So my diagonal matrix will be P inverse AP. 4 plus 3 is 7. 6 plus 15 is 21. 4 minus 2 is 2. 6 minus 10 is negative 4. $14 minus 21. That didn't work. What did I do? 1, 2. Huh? Oh, sorry, it's 14 plus 21 is 35. Then I've got 21 minus 21 is 0. 4 minus 4 is 0. 6 plus 4 is 10. There we have diagonalized matrix A by changing it to a basis consisting exclusively of eigenvectors of this matrix. Notice that it is a diagonal matrix with the eigenvalues of the matrix on the diagonal. Matrix A is similar to this matrix. So that means that the determinant and the trace of matrix A are the same as the determinant and the trace of matrix D. The determinant of this matrix is 20 minus 6 is 14. Clearly, that's also 7 times 2. And the trace of this matrix is 4 plus 5, which is 9. Clearly, that's also the trace of this matrix. Right?